Hello, this is Kent Dilling with Fertilizer Dealer Supply. And what we've got is an SCS660 console that we're going to talk through programming from just coming out of the box. And so you see it's flashing CAL. It's got some questions that we have to answer, and then we're going to do programming of it. And I just wanted to take you through this. The reason we're using the 660 is we're going to do for granular programming. So the first thing that comes up is volume per acre US, and we go through, there's standard empirical, and there's turf. And the one we're going to do is US volume per acre. So I use CE to toggle, and I press enter to lock it in. Next up is it's asking us, do we want SP1 wheel drive? That would be magnets. Not many systems use that anymore. Most people use what is SP2 or the radar, and this is also what we use when we're using GPS. GPS simulates radar is what we have. So we're going to lock that in by again pressing the enter. And on the 660 we have liquid, we have granular, one, which is a single bed belt, which is what we'll do for a pull type spreader. And then they also show that we have a split belt, which is some of your truck applicators have that. But in this case, we're going to go back to granular. And then we're going to go ahead and lock that in with our enter button. Next up is the type of valve. So there's a standard valve. That would be where you had another on-off valve, and this is just a control valve. There's a fast valve, control is fast valve. And then there's a CFC or a fast close valve. So this is a fast operating valve that also will work for our on-off valve. And that's actually the valve we're going to use for this application. I'm going to show you also there's a PWM, which is a pulse width modulated valve. And then here would be the other one that we'd use for granular is a pulse width modulated close valve that would work for control as well as on-off. Coming back, that's actually a new leader valve. And then we're coming back to the fast valve. So that's the one we want to select. We're going to use enter. And now we're ready for the calibrate the top row. That's what these buttons are here. We still see it still, even though we've answered those questions, it's still calibrating. We go to boom 1, and I'm going to go ahead and do this for a single swath. And so I'm going to press enter. You see the red light comes up there. At this point, the numbers become active. And I'm going to go ahead and put in 720 and then enter it. So now we have boom 1 at 720. We could toggle up and down and do all the additional booms if we had them on a liquid system. In this case, we just have the one boom, the one width. We're going to do speed cal. In this case, I'm just going to act like I'm using a GPS that is simulating radar, and in this case I'm going to put in a number of 595. You can simply program over the top of that if it changes, or if you've got radar and you're calibrated, you just program over the top of that. On the meter cal, we've got something a little different. I've got a transducer here that's going to read that. Encoder, sorry, and there's the part number for the encoder. But what I've got here is it tells us that it is a 180 pulse encoder. Now I don't put that number in. What I do is I use that number and I go to my spreader manual, and I can see that if I've got a 18-inch chain and I've got a 180 count, that I've got a constant that comes up because of that number, that would be 312 for the gate setting that I have. So I'm using a Chandler manual. I'm selecting the 180 count. I'm selecting the right belt or the right gate opening and the right belt width. And I'm using all those numbers to give me a number of what my meter cal is going to be. Now, on the meter cal, I actually have to hold this down. And there it gives me the spreader constant. So that's where I'm going to put in the number out of my manual. So in this case, I'm going to put in enter 3, 1, 2. If I go away from that and then come back, you'll see what it shows me is my density. The reason density is behind that number is because it's actually accumulation of the spreader constant and the density of our product. I'm going to go ahead and change our density from 0 to, in this case, 65. And see, there's a decimal there that I need to compensate for. So there we have 65 pounds is the weight of the material per cubic foot. If I want to get back to my spreader constant, I have to hold this button down for 5 seconds. The reason it's built like that is because the most common thing you'll change is your product density. As you go from material to material, that may vary. Your spreader constant would stay the same because the gate would be the same. But there's certainly cases where you change one or the other. And like I said, you're going to be really close with this out of a Chandler manual. You can also do a catch test if you want to get closer on it, if you see that you're running a little higher, running a little low. Next up, we're going to go to valve cal. And remember, we set a fast close valve. And so this number is going to be right off of the valve, 743. And then rates, here's where it gets interesting. With a granular system, your rate can vary as much as you want because it's just simply the rate of the bed that you're doing. So in this case, we're going to go ahead and put in that he's going to run 200. And then we'll also put in on rate 2 that he's going to put in 300. At that point, you can see that we quit flashing cal. The console is now ready to operate. It's fully programmed. That's significant when the cal goes away. We can go ahead and enter the tank volume, in this case in pounds, and that will count backwards. But if you want to have an ongoing tank volume, you're going to have to put that back to your full tank volume every time you refill or whatever level that you put into it. So with that, we're ready to go back and we can use this bottom row to see where we're at as far as accumulating on volume and area. But we're ready to put it into rate 1 and then simply use the master to turn it on and off. Thanks.